Good afternoon, everybody. Well, good afternoon. So, first of all, before starting, just let me know if my video is visible to you and my audio is audible to you. Yeah, please quickly let me know so that we can move forward confidently. All right. Thank you so much. So, maximum of you are able to hear me and also able to see me. All right. So, today we will continue with binomial theorem. In the previous class, we have done general term, middle term, and binomial expansions. We have done those things. So now for today, we will start with properties of binomial coefficients. Properties of binomial coefficients. And before starting that, what are the properties that C naught, C1, C2? You remember this thing? That C naught, C1, C2, those are binomial coefficients. Getting my point? So C naught, C1, C2. Now, if you remember, expansion we have done of a plus x raised to the power n. Now, if we talk about the expansion of 1 plus x raised to the power n, this expansion is going to be nc0 plus nc1x plus nc2x square plus nc3x cube and so on ncn minus 1 x to the power n minus 1 and ncn x to the power n. So this is the binomial expansion for 1 plus x raised to the power n. Am I correct? Now in this equation, if I put x equals to 1, if you put x equals to 1, we get a result that nc0 plus nc1 plus nc2 plus nc3 and so on ncn minus 1 plus ncn. This will be 2 raised to the power n. First important result it is. Got it? So this is our first important result that nc0 plus nc1 plus nc2 plus nc3 up to ncn is equals to 2 raised to the power n. Sri Lakshmi, please do something for you because I think everybody is able to hear me. Am I audible to all of you? Thank you so much. So, first thing is this. This is what I call total ways of selection. Total ways of selection. Now, how is it total ways of selection? See, like we have n distinct objects. So, what are the total number of ways of selection is what? I do not select any object, that is nc0, or I select one object, that is nc1, or I select two objects, that is nc2, and so on, or I select all n objects, that is ncn. Got it? In the right side, if I see, with respect to every object, it has two ways. Either it is selected or it is rejected. If I see in the right side, every object has two ways. Either it is selected or it is rejected. Second object also two ways, selected or rejected. So there are total n objects. So total ways of selection is what? 2 raised to the power n. So this is basically permutation wise. If I see, it is total number of ways of selection. And if I see just by binomial expansion, you expand it, you put x equals to 1, you get the result. Got it? First very important result. Now, if I put x equals to minus 1, what do I get? nc0 minus nc1 plus NC2 minus NC3 and so on minus 1 to the power n NCN. And this is going to be 0. This is second important result. Got it? So NC0 minus NC1 plus NC2 minus NC3 up to minus 1 to the power n NCN is 0. Now, if I add both of them, add 1 and 2, what do you get? You get twice of NC0, twice of NC2, twice of NC4 and so on. Up to which point it goes, that depends on if n is even or odd. So I'm not marking anything up to. So it is 2 raised to the power n. Have a look. So this is equals to 2 raised to the power n. So if I divide the entire equation by 2, you get NC0 plus NC2 plus NC4 and so on. That is 2 to the power n minus 1. This is third important result. Got it? Now, fourth, if I subtract 1 and 2, you get NC1 plus NC3 plus NC5 and so on. That is also 2 to the power n minus 1. Got it? Now a very simple question you write. Find the value of NC0 plus NC2 into 2 square, NC4 into 2 to the power 4 and so on. What it is? NC0 plus NC2 into 2 square plus NC4 into 2 to the power 4 and so on. Just do it quick. Now see, it looked like that x has been replaced by 2. So in the expansion of 1 plus x to the power n, that is NC0 plus NC1x plus NC2x square and so on. Now if I replace x by minus x, So you get 1 minus x raised to the power n as nc0 plus nc2 x square and so on ncn minus x raised to the power n. Now if I add both of them, I get 1 plus x raised to the power n plus 1 minus x raised to the power n upon 2 will be nc0 plus twice of, okay, 2 to already utilized, nc0 plus nc2 into x square plus nc4 into x to the power 4 and so on. Up to which point it goes, that depends. Now put x equals to 2. So 3 to the power n plus minus 1 to the power n upon 2 is equals to nc0 plus nc2 into 2 square plus nc4 into 2 to the power 4 plus and so. Am I clear? Now, fifth, prove that nc1 plus twice of nc2 plus thrice of nc3 and so on n times ncn. It is n times 2 to the power n minus 1. All right. Any idea? Any idea if anybody would like to try it? Yes, Manish. Manish, can you switch on your mic?
Yes.
How to do? Any idea?
No.
Roshan? Roshan?
Yes, sir.
Beta, any idea how can you do this?
No.
Vaishnavi? Vaishnavi? Sri Lakshmi, am I audible now? Manish?
Yes, sir.
Which, any ideas? Some idea at least? See, I will give you two ways to solve it. Even I can give you multiple ways to solve it. I'll give you three ways. See, method one. See very carefully, they are very important. Let us assume this series is NC1 plus twice of NC2 plus thrice of NC3. Last term is n times NCn. Previous term is n minus 1, NCn minus 1. Yes or no? Now let us write this series once again. Now this n times NC0, this term, NCn is also NC0. So I write this term here. So it is n times NC0. Got it? Even before this, I write 0 times NC0. This is S. So that n times NCn is written as n times NC0. This n minus 1 times NCn minus 1 is what? N minus 1 times NC1 plus n minus 2 times NC2 and so on. Now this will be 1 time NCn minus 1 and last it will be 0 times NCn. So what did I do basically? I replaced every NCR as NCn minus R. Correct? Now you add both of them. So see, left side it will be 2s. Now what is this summation? Isn't it n times NC0? What is this summation? It is n times NC1. It is n times NC2. And so on. What is this summation? N times NC n minus 1. And what is this? It is n times NCn. Am I correct? So 2s is what? N times NC0, n times NC1, n times NC2, n times NCn minus 1 and n times NCn. Now if I take n common from this, you are left with NC0 plus NC1 plus NC2 and so on NCn minus 1 plus NCn. And value of this NC0 plus NC1 plus NC2 up to NCn, we just calculated it is 2 to the power n. So it is n times 2 to the power n. So this implies S will be what? Divide by 2, so n times 2 to the power n minus. Tell me if you get it. Note it down very carefully. Have a look, everybody. Got it? Now, see method 2. This was method 1. Method 2. Now, this S is what? S is sigma R from 1 to n R times NCR. This is NC1 plus twice of NC2 plus thrice of NC3 and so on and so forth. Now see very carefully. R from 1 to n R times. This will become n factorial upon R factorial n minus R factorial. That is sigma R from 1 to n R into. This can be written as n into n minus 1 factorial. Denominator can be written as r into r minus 1 factorial and n minus r factorial. So numerator में n factorial I replaced by n into n minus 1 factorial. Denominator में r I replaced by r into r minus 1 factorial. This r cancelled. So what you are left with? R from 1 से n outside, n minus 1 factorial upon r minus 1 factorial, n minus r factorial. Now see, n came outside. This is sigma r from 1 to n. This entire quantity, this. Isn't it n minus 1 c r minus 1? Tell me. Yes. So n times. Now if you replace r, it will be n minus 1 c0 plus n minus 1 c1 plus n minus 1 c2 and so on n minus 1 c n minus 1. So this will be what? N times 2 to the power n minus n times 2 to the power n minus 1. Have a look. See, every method has a limitation. This method might not be applicable in the next question. Got it? Am I clear? Now go for method 3. Manish, Roshan,
Yes, sir.
can you tell me the derivative of x to the power n?
N into x to the power n minus 1.
Very good, very good. Is there anybody, Vaishnavi, Lakshmi, Manish, who are not aware of this thing? The derivative of x to the power n is nx to the power n minus 1. Vaishnavi? Vaishnavi? What is this derivative? Vaishnavi? Manish, are you aware? Very good. Then we will do it using this method also. See, 1 plus x to the power n. This is what? nc0 plus nc1x plus nc2x square plus nc3x cube and so on ncnx to the power n. I will differentiate this entire equation. Differentiating with respect to x. Now, if I differentiate it, it will be n times 1 plus x to the power n minus 1, right side. Derivative of nc0 constant 0. Then nc1 derivative of x is 1. Then nc2 derivative of x square is 2x. Then nc3 derivative of x cube is 3x square. And so on ncn into nx to the power n minus 1. Now directly put x equals to 1. So if you put x equals to 1, right side you get nc1 plus twice of nc2 plus thrice of nc3 and so on n times ncn, and left side we get n times 2 to the power n minus 1. Got it? So this is a third approach for this particular expansion. Now with this expansion only, see in this, if I put x equals to minus 1, then nc1 minus twice of nc2 plus thrice of nc3 minus 4 times nc4 and so on, it is going to be 0. it is going to be 0. Now, if this is equation, say 5, and this is 6, add 5 plus 6. So, twice of NC1 plus thrice of NC3, 5 times NC5, and so on, wherever it goes, it will be 2 to the power n minus 1. Now you divide it by 2, then NC1 plus thrice of NC3 plus 5 times NC5, 7 times NC7, and so on. And this is equals to 2 to the power n minus 2. I won't say it is an important result, but yes, it is also a good result. Got it? Now, next, very, very important again. Prove that NC0 square plus NC1 square plus NC2 square and so on NCN square. This is 2NCN. Give it a try one moment. This is 2NCN. Integration is correct, but that integration won't be used here. Integration, what you told, x to the power n is x to the power n plus 1 upon n plus 1 rationally, that is fine, but that won't be used here. Roshan, where are you from?
Tinsukia,
Tinsukia,
Assam.
Assam. So are you on leave these days?
Sir,
Are you on leave these days or you are in school?
sir, in home.
At home?
Yes, sir.
So holidays till what time?
Sir, till 4 November.
Till 4th of November. Long holidays.
Yes, sir.
So how are you going to kill your time?
Sir, through this class.
My class, like we are having classes only 2 days. See, now when you have time enough, I think you should do something really like big for your JEE preparation.
Yes, sir.
Like we are going through these concepts, revise them again, try some book, any book you can take from the market and try questions from that book also. Because nothing would happen unless you try on your own. Isn't it?
Yes, sir.
Okay, and where is your school?
Sir, in Tinsukia.
And your home is also in Tinsukia.
No, in village, one village, Dhola, sir.
That is also in Assam.
Yes.
Okay. And you, Manish? Manish, where are you from?
Sir, same Tinsukia.
Sorry?
Tinsukia.
Same Tinsukia.
Yes, sir.
Same school.
Yes, sir.
Okay. And Sri Lakshmi? Vaishnavi, where are you from?
Vijayanagaram, sir.
This Vijayanagaram is not Vijayawada?
No, sir. In AP, other than Vijayawada, sir.
Okay,
There is
okay.
Vijayanagaram also.
And where is your school?
Escota, sir. Kiltampalam.
Okay. So your holidays is till what time?
Till 3 November, sir.
And holiday scheduled from which date?
9, sir.
From 9th, I mean, like it's already been a week you are at home
Yes, sir.
and going to be at home for next 3 weeks.
Mm,
Oh my God. So enjoyable days for you, isn't it?
yes, sir.
So how do you kill your time at home these days? What do you do? Vaishnavi, who took your interview?
Sir, I don't know, sir.
Okay. Is there anybody out of you whose interview was taken by me? Okay. Vaishnavi, tell me one thing. Have you done permutations? Vaishnavi,
Yes, sir.
have you done PNC in school? Roshan,
Yes, sir.
have you completed PNC?
Yes.
So tell me, there are n boys and n girls. Okay. And we want to form a committee of total n guys. Then how can we form it?
Two NCN.
2 NCN. Okay. If I want to start counting using boys and girls wise, then how can we do it? Did you get my question?
No, sir.
I am saying this 2 NCN is fine, totally perfect. Now what I'm saying, you want to start counting, like you do not select any boy or you select all the girls, that is a way. Or you select one boy and n minus one girls, that is another way.
Yes, sir.
You select two boys and n minus two girls, another way. And so on, you select all boys and you do not select any girl. So that consider all the cases which are required. Yes or no?
Yes. Yes, sir.
So right side of this. Now the method one I'm telling you now first. We have n boys and n girls. Need to make a committee of n students. So since there is no restriction, total ways can be 2 NCN. Yes or no?
Yes, sir.
Total ways can be 2 NCN. Now if I start selecting student wise, NC0, NCN. First N is for girls. So you did not select any girl, you select all boys. Or NC1, you select NCN. All N boys, no girl. Or one boy, NCN minus one girls. Or two boys and NCN minus two girls. And so on. All N girls and no boy. Am I correct? Am I correct?
Yes, sir.
Now, if you realize this NCN is basically NC0, this NCN minus 1 is NC1, this NCN minus 2 is NC2, and this NC0 is NCN. So, this is basically NC0 square plus NC1 square plus NC2 square and so on NCN square. That is 2 NCN. Am I correct?
Yes, sir.
So, this is one way of doing it. Done. Now see method 2. 1 plus x to the power n is what? 1 plus x to the power n is what? This is nc0 plus nc1x plus nc2x square and so on ncnx to the power n. Am I correct? Now replace x by 1 by x. So 1 plus 1 by x raised to the power n is what? nc0 plus nc1 upon x plus nc2 upon x square and so on ncnx to the power n. Ncn upon x to the power n. Got it? Now multiply the entire equation by x to the power n. So 1 plus x to the power n is nc0 x to the power n, nc1 x to the power n minus 1, nc2 x to the power n minus 2, and so on ncn x to the power 0. While you multiply by x to the power n. Now we have two equations. Say this is first one, this is second one. In the product of these two equations, in this product, compare coefficient of x to the power n both sides. So left side में तो it will be coefficient of x to the power n in 1 plus x to the power 2n. Right side में see how will you get x to the power n if this nc0 is multiplied by this ncn. So it will be nc0 ncn. Then it will be nc1 ncn minus 1. Then it will be nc2 ncn minus 2 and so on. It will be ncn nc0. Now you correct it. So coefficient of x ki power n in 2ncn will be 2ncn is nc0 square plus nc1 square and so on ncn square. Am I correct?
Yes, sir.
Very good. So this is how we can also approach them using comparison, comparing coefficients. Take a look. Got it? Now, another is nc0, nc1 upon 2, nc2 upon 3, nc3 upon 4, and so on, ncn upon n plus 1. This is 2 to the power n plus 1 minus 1 upon n plus 1. How do you prove it? Get done with it quickly. See, now you have 1 plus x raised to the power n is nc0 plus nc1x plus nc2x square and so on ncnx to the power n. All right. So now do one thing, integrate both sides. Clear? Now integration left side will be 1 plus x to the power n plus 1 upon n plus 1. Let us put the limit of integration from 0 to 1. This is also from 0 to 1. Right side will be nc0 plus nc1 into x square by 2 plus nc2 into x cube by 3 and so on ncn into x to the power, this is in the numerator only, into x to the power n plus 1 upon n plus 1 and limit from 0 to 1. Am I correct? Now just simply put the limit. It is 2 to the power n plus 1 minus 1 upon n plus 1 is nc0 plus nc1 upon 2 plus nc2 upon 3 and so on ncn upon n plus 1. Correct? See, have a look. Very, very important again. This can also be done using without integration. Vaishnavi? Vaishnavi?
Yes, sir.
Did you get it? Vaishnavi? Roshan, did you get that?
Sir,
Tell me.
could you explain again?
Yeah, why not? See, before that, are you aware that integration of x to the power n is what? Are you aware of that?
Yes, sir.
What's that?
N into x to the power n minus 1.
Although that's derivative. That's derivative might
No,
change.
sir. I will tell x power n plus 1 by n plus 1, sir.
Yes, it is x to the power n plus 1 upon n plus 1. This is integration, which is reverse of differentiation. So what did I do? I integrated both sides. So left side integration is 1 plus x to the power n plus 1 upon n plus 1. Right side में 1 का integration x integration is x square by 2. Integration of x square is x cube by 3. Integration of x to the power n is x to the power n plus 1 upon n plus 1. Correct? Now put the limits from 0 to 1. I hope I made my point clear.
Yes, sir.
Now you guys need to prepare more on your own from this topic. Next class we'll do few questions and then we'll move to the next chapter. All right.